Hey everybody, it's me Leaf back with part 3 of our Solidity Beginner tutorial. And again, thank you guys so much for watching, really appreciate it. And if you did find this video useful, please hit that like button, it means a lot to me. It also can push this video out on the YouTube algorithm to other developers who are trying to learn this information. So thanks, really appreciate it. Today we're going to be talking about well, first of all, we're going to be talking about payable, the payable keyword. We're going to be talking about constructors, more on functions, and another thing spicy at the end we're going to be doing as well. So let's start out today by making an address owner. This is going to be just a variable, state variable we put here. And now we're going to talk about a constructor. So what is a constructor? Well, it's a function that gets run when the contract gets deployed to the Ethereum network. So this runs one time, and you cannot call this outside of this. So this constructor runs one time. And what happens here is owner gets sent to message.sender. What is message.sender? This is a keyword in Solidity that means whoever is the address that called this function. So basically whoever deployed this contract is going to get set to owner. So now we have this owner variable here, and we can call it, we can make this public. I'm sorry, I keep doing this. It's actually here. We can make this public. And if we were to compile this contract and deploy it, here we can tap owner, and we're going to get an address, and it's going to be the same address of the account that deployed this to the network. Pretty simple, right? Not too complex. So let's make another function here and call this change owner. So if we were to change owner to another contract or to another account, to another address, we want to do this line here called require. So what is require? This is another special thing in Solidity. It's a special function in a way. When you call this, it takes two parameters. Well, technically one parameter, but we can make it two. Require makes this first statement needs to evaluate to true. So if message.sender does not equal owner, this whole transaction will get reverted, and then the gas will be returned. Then the second part is just a message to the person who failed this require statement. So we do the require here, and then owner equals new owner. You notice here in the change owner, it takes a parameter of address of a new owner, and then so we pass it a new owner, and that should switch the owner variable. Let's compile this and deploy this to the network using another account. Let's use this second account here and deploy it to the network. So who's the owner now? Well, it is the second account that I deployed with. Now let's change owner to this account. Let's copy that account, and here we can change owner, and now let's check owner. Wow, it changed. Let's try to use this account, who's not currently the owner, to change accounts, or to change the owner to this account. Oh, look, we got a revert. Now, if we check the information logs here, we can see that this got reverted, and this is the transaction hash and everything. So we can notice all this, that it got reverted, and only the owner can change the owner, of course. So that's kind of a little cute thing that we did here. We have we figured out how to set an owner on Solidity. So next thing we're going to do is we're going to make a payable constructor. So in Solidity, or on the Ethereum network, anything with an address can store Ether. So whether that is a smart contract or whether it is a wallet, a user account, this can all store Ether, which is the native cryptocurrency of Ethereum. So on cryptocurrency exchanges, you'll see Ether is trading at whatever price. This is the same thing. So if we were to make a constructor and make it payable, then we can send Ether or any subset of Ether into this contract, and this contract would then have money inside of it. So let's make this constructor payable. And let's have this function here called check balance, and then return, we'll talk about this in a second. This returns a uint, of course, because it wants to return how much ether is currently stored on the contract. And then we have this new keyword here called view. So this is a concept on the Ethereum network that you're going to have to understand. Everything on the network costs something to transact, because that's just how the network works. Somebody has to do the computing of every function, every variable call. Somebody has to do that computing. If you are viewing the state of the network, your machine can run it, so it's kind of free in a way. When you change the state, you have to get validated by miners. Miners have to validate this transaction, so you have to pay gas. That's a way to incentivize miners to use their computing power to power the network. So when you have a view function means that this function, we tell Solidity, this function does not change the state of the smart contract, does not change any variables, does not have any permanent effect on the network. We are just viewing either a variable or viewing the state of the network, something like that. So that is what view is, as opposed to another thing called pure. Pure, on the other hand, does not, well, we'll talk about that in a second. Let's just think about view right now. So remember, there's view and pure. Keep that in mind. So to return, we're going to return the address, this dot balance, which is a little shorthand keyword of returning the current ether balance of this contract. So let us compile this. We compile. Now we're going to deploy this, and we're going to send it 10 ether. Deploy and send 10 ether to this contract. So we're going to check balance. And now we have this big number because in Ethereum, on the Ethereum network, ether is actually the main category of currency. Wei is like the penny of an ether. It's one with I think 18 zeros after it, maybe 16 zeros after it. That's actually what an ether is in Wei. So just think of it as a subset of the currency. There's no decimals here. It's all done with an actual integer. So just keep that in mind. So when you see this really big number here, this is actually 10 ether. So if we were to send, so now this contract is pretty bad because we just sent 10 ether into it, and we have no physical way of getting this ether back. And smart contracts are immutable. So that means they can never change. So if you were to actually deploy this and send 10 ether to this contract, in actuality, you have just spent a ridiculous amount of money for literally no compensation. At the time of me making this, you just spent $20,000 to deploy this contract, and you can never get that money back, which is pretty horrible. So that's why you need good smart contract developers to make very high functioning, no bug contracts. All right. One thing, so now we have the view, and let us compare this with a pure function. So I'm going to delete this here and paste in a pure function. A pure function neither changes the state of the Ethereum network or makes a call to the state. So that means it doesn't view any variables. It also does not change any variables. Kind of. So an example of a pure function would be to do math. This is a very expensive calculator, but it returns a uint and returns 1 plus 1. So this is a pure function because it doesn't view any variables, and it also does not change the state of the network. So that's what a pure function is. And pure functions and view functions both have their place. Let's just reiterate the example of a view function. We have this integer here called uint256, and number equals 2. And then we have this view function that returns a uint and just returns this number. So that's a great way to think about it. And why does this matter? Because every computation in the network requires processing. So if you call a view or pure function from a local node, you don't pay gas because your local node does the computation. But if it's called from within a smart contract, it still costs money, but less. So keep that in mind. This is a way to optimize your gas savings. So when you're writing contracts in the future, always label functions as they are needed. So if your function only views, label it view. If your function is pure, label it pure, and you'll save money in the long run. All right. Thank you guys so much for watching part 3. Let's get on to part 4. See you guys in the next video.